Hi, everyone. Welcome to Foresight's Intelligent Corporation Seminar Group. We have our first seminar in 2026. We're going to start with the Norm Hardy Prize Award ceremony for the Norm Hardy Prize Award of 2025. We already had the pleasure of welcoming Pardis in person to our Vision Weekend and giving you the actual physical trophy, but it's also really nice to see you here virtually and share your research and your progress with a little bit more of a broader community. So this talk is recorded. It will be on YouTube afterwards. A little bit more context on the Norm Hardy Prize. Some people here in this audience are much more familiar with the fantastic progress and pioneering work that Norm Hardy has done for computer security. I think in a nutshell, what this prize is trying to honor, apart from him as a person, is especially his work on not just making systems more secure, but also on focusing on usable security. So actually making secure systems usable. And so that is what this prize is awarding, really trying to focus on usability of secure systems in various different ways. Now, without further ado, I'm super excited to welcome Pardis on stage. You're an assistant professor of computer science at Duke University, and you'll be presenting on IoT security and privacy labels. So thank you so much for coming. And we have a few people that are actually much more familiar with Norm and with the prize here in the audience, including Dean Tribble, for example, who is one of the sponsors of the prize. We have Chris Hibbert here. Really excited to have you too. So hopefully we can draw on you for asking lots of questions in the Q&A. Thank you so much, and the stage is yours.
Thank you so much, Alison. And first of all, thank you so much for honoring me with this amazing award. I really appreciate that. And hopefully today I can tell you more about basically the research that you've done to basically design this label, all the projects. So let me start by sharing my screen. Share. Okay, awesome. Oh, actually, let me continue to share. Okay, could one of you please let me know if you can still see?
Looking good.
Perfect. Wonderful. Awesome. And I do not have your basic screen in front of me. Like I cannot see the faces, but if you have any questions, please just unmute yourself and ask. Okay, so thank you so much again for the introduction. My name is Pardis Emami-Naeini. I'm an assistant professor of computer science, electrical and computer engineering, and public policy at Duke University. And today I'm going to basically talk about the journey that basically we've taken to design an informative and usable security and privacy label for smart devices, for Internet of Things or IoT technologies. But first, let me start by talking about toilets. And not regular ones, but the smart ones. We have very smart toilets on the market that are enabled with Amazon Alexa that could light up, or even better, flush for you with your voice command. We're also going to have a much smarter one equipped with several sensors, including cameras that could identify you and collect your health-related information. And now with generative AI, we're going to have conversational smart toilets as well, so that you can share your deepest thoughts and feelings, basically, and have them as companions. But these technologies, in theory, could be very useful. Maybe, for example, in identifying health issues. But they could also pose huge risks to users' privacy, especially if users are not aware of the device's security and data practices. For example, imagine a scenario where your inferred diagnosis gets shared with your employer or insurance company without your knowledge. People currently are increasingly purchasing these technologies, these smart technologies. However, despite the surge in purchasing them, consumers are still very concerned about these technologies' security and privacy practices. But the question is how much they can realistically do at the time of purchase to make better and more informed, basically, decisions about these technologies. Many of us have the experience of purchasing a smart device for ourselves or others. It could be a smart speaker, a smart thermos, a security camera, a wearable technology. Now, I want you to remember the time when you were either in a physical store or online searching for a smart device to buy. Well, you probably saw information about the price of the device, its specification, technical specification, for example, its size, internet connectivity. But do you remember seeing any information about the device's privacy or security practices at the time of purchase? Well, probably the answer is either no or yes, but it was in a long privacy policy that I did not read and I was not planning to read. So currently, that's basically the situation. When purchasing a smart device online or in a store, consumers are not exactly able to make informed decisions about these technologies' privacy and security practices. Basically, they cannot compare which device is more secure, which device is not sharing my information to random third parties, because this information is not readily available to them. So, one way to potentially address this information asymmetry between the device companies and the device consumers is to make security and privacy information available and usable at the point of sale. To this end, I took a 6-year journey to design a usable and informative security and privacy nutrition label for smart home devices. Following our strong empirical evidence that US consumers are increasingly interested in having such labels for their internet connected technologies, we presented our research at the White House Security Summit. And our research informed the current smart device labeling program in the US, known as the Cyber Trust Mark program, which is currently overseen by the US Federal Communication Commission, or FCC. And the goal here is to promote enhanced cybersecurity practices across basically the smart device industry through point of purchase labeling of these devices. So to design this label, to basically get to this point, to have this label and to have these conversations with the regulators, I had to conduct several projects to basically show that all consumers want to have such a thing. And then I could have needed to design the label and test the label to make sure it's effective. And today, basically, I'm going to talk about the main projects that I did to design basically this label, starting with the first project. So at the beginning, my goal was to basically just understand whether consumers even want to have such transparency at the time of purchase, if they even care about having such a privacy and security label for their smart home devices. So in this study, I wanted to show consumers a reasonable prototype label that includes some important security and privacy information. And to design this first version of the label, this prototype, I conducted an extensive literature review of more than 70 IoT security and privacy references from academia, governmental organizations, both in the US, including the National Institute of Standards and Technology, NIST, and international ones, such as the CMS in the UK and ENISA. Nonprofits, such as Consumer Reports, as well as several guidelines from companies, for example, AT&T, Intel, Microsoft, Symantec, and several others. Based on these survey documents, I designed the first prototype of my smart device label, which is basically shown on the slide. As you see here, this version of the label is very similar to a food nutrition label. And now we have 3 sections: general information, privacy information, and security information. On the general information, we talked about the name of the device, the brand, the version number. On the privacy side, we talked about the type of information the device collects, the purpose of data collection, retention time, and some other information. And for the security side, we talked about whether the device receives automatic security updates, the lifetime for the updates, whether users have any choices regarding these updates, and some other information. And all these factors were coming from the references, basically, that I surveyed, these 70 references that I mentioned in the previous slide. I then interviewed smart device consumers to capture their feedback on this first version label, on this prototype label. Almost all participants, almost all consumers reported that they would like to know about the privacy and security of their smart devices before making device purchases. So they liked the idea. And basically from the study, I found the motivation that I was looking for, that right now, it is very challenging for consumers to find this information at the time of purchase, and they would appreciate having such labels to help them compare smart home devices according to their security and data practices. One of our participants said, as opposed to those long policy documents that you usually need to read, I think this is a very efficient way, and I cannot think of a better way than this. There are several pieces of legislations that have been proposed over the past few years in the US and in a few countries outside of the US, including UK, Singapore, Finland, Germany, Australia, that would require IoT labels. So there are legislation that basically would say that we need to have labels for smart devices, cybersecurity labels for smart devices. Some even mention a few factors that these labels should include, but they don't really contain too many details about how these labels should look like, what should be the content of these labels, and why. Like they may propose something, but there's really no evidence that their consumers would even want that information. And as you can see from the titles, these proposals are primarily focused on security and not much on privacy. So, my next goal, my next project on this journey was to basically understand what should be the content of these IoT security and privacy labels to make them usable and informative, which is basically the second project I'm going to talk about. To capture a holistic view of the desired content of the label, I talked to and I surveyed a diverse sample of security, privacy, policy, and IoT basically experts from industry, academia, government, and non-governmental organizations. The recruited experts had to satisfy at least one of the following criteria: being a faculty member in the field of security and privacy, having at least 10 years of research or practice in privacy, security, or policy, being an author of known books in the field of privacy and security, having active involvement in cybersecurity standardization, or leading an IoT product team in industry. After talking to experts, our experts acknowledge the value of label in informing consumers' purchase behavior. One of our experts said, what's good about a label is that it empowers the consumer to make a more active decision about cybersecurity rather than just being completely helpless as to what the security of her device might be. The average consumer doesn't have a privacy, security, or legal department to review this stuff before they buy it. Enterprises do, but consumers do not. So someone's going to be looking out for consumers and giving the consumers this information. In addition to informing consumers' purchase behavior, some of our experts predicted that if the label gets adopted, it could initiate a competition in the market for device manufacturers to enhance their security and privacy practices, their underlying practices. An expert said, there is value in forcing the company to write a list down, even if the consumer doesn't understand it. If you said, list your open ports, there would be an incentive to make them feel. So our experts wanted us to include around 47 privacy, security, and general attributes on the label, which is clearly too many to show on a typical product package. Therefore, we decided to design a layered label with 2 layers. The primary layer is the concise format of the label, which could be printed and attached to the product. And then there is a QR code and a URL that would direct you to the secondary layer, which has more detailed information and is in an online-only format that can be updated as firmware changes. And having this online layer is actually very important as these devices get updated often. And also, we wanted to make sure that the companies have a way to basically communicate how things are being changed in terms of privacy and security to the users. And having this secondary layer would actually accommodate that. So what I did next was to assess the label's usability and information communication. And I tested this with actual real consumers of smart devices. So I basically evaluated the label's risk communication and information communication in both non-comparative and comparative purchase processes. Started with the non-comparative process, and I asked participants to take a look at the package of the smart device with the label. I asked them to define each of the attributes as well as the information in front of them, as well as their values. I then ask them to specify the information that conveys risk to them. In the comparative scenario, which is the image on the right side, participants imagine doing comparison shopping for a smart device from two different companies. I asked them to compare the labels and specify which company had implemented better privacy and security practices and why. So based on the results, a few of our participants preferred the single layer label. So for example, just the primary layer. Mainly because of this perceived inconvenience of using their phone, for example, to scan the QR code or type in the URL. And some participants reported that they kind of feel that having this secondary layer, it's as if the company is deceptive. It's hiding some information from them by putting this information on the secondary layer. However, most participants, they wanted to have this layered privacy and security label because a layered label would fit more information and that they would readily get insight about the additional information from the primary layer, as well as if there's something else about the company that they want to know about, if they want to know about it. So they were saying that I can get the gist of information from the first layer. If there's something more, there is a way for me to get that information, as opposed to, again, reading privacy policy or alternatives. As we expected, some of the information on the secondary layer was not understandable to our consumers. For example, devices, ports, and protocols. However, still most participants wanted these labels to be as comprehensive as possible so that there is a way for them to understand about the privacy and security practices of their devices if they want to. One of our participants said, I don't know what TCP and UDP are, but it's interesting to have this here because then I could go to Reddit and ask on there what that means and what the capabilities are. Some of our consumer participants reported that our label is useful in informing both consumers as well as experts. A participant said, labels are both for customers and experts, such as tech journalists and consumer advocacy groups. If they see something that is questionable, they will raise it in the public press or will raise it with regulatory authorities. The label is not just for the consumer, but there's another feedback process that works through experts. In an iterative process, we applied several wording and design changes, and this is the next version of our label. So until this stage, our focus was to design a label that conveys critical security and privacy information in an understandable format so that the comprehension was our goal so far. But in addition to being understandable, it is actually important for the label to convey risk to consumers and even impact their purchase decision making, their purchase behavior, which is what we tested in the next project. So I surveyed 1,371 consumers of smart home devices from a crowdsourcing platform. In the survey, I presented several purchase scenarios to participants. Each scenario asked participants to imagine purchasing a smart device with a privacy and security label, and that the label talked about only one privacy or security attribute. This is an example of a scenario that I presented to participants. Imagine you're making a decision to purchase a smart speaker with voice assistant for yourself. The device has a microphone that will listen and respond to your voice commands. The price of the device is within your budget, and the features are all that you would expect from a smart speaker with voice assistant. On the package of the device, there is a label that indicates the following practice: purpose of data collection, tailored advertising and monetization. So the words, these red words inside the bracket, are the factors that we varied across the scenarios, and we quantitatively measured their impact in consumers' risk perception and desire to purchase smart devices. At the end of each scenario, we asked participants to specify on a Likert scale how each attribute would change their risk perception and their willingness to purchase, and why. I then quantitatively measure the impact of our labels, security, and privacy factors on consumers' risk perception and their desire to purchase. For each attribute on the label, I selected two values that I hypothesized to be most protective and least protective. For example, for the purpose of data collection, I selected providing main device function as the most protective value and monetization as the least protective value. I hypothesized that most protective values of attributes should significantly decrease the risk perception and increase willingness to purchase, and the exact opposite for the least protective values. The statistical results showed that consumers perceived a significantly higher risk for smart speaker compared to the smart light bulb. So basically, that means that the type of device was a statistically significant factor in changing participants' risk perception and desire to purchase. However, the analysis showed the device recipient had no significant impact on participants' behavior, basically. So if you're purchasing a device for yourself, if you're going to gift it to someone else, that's not going to change your risk perception or willingness to purchase. I then conducted regression models, constructed regression models, to basically measure how different attributes of the label would change risk perception and willingness to purchase. And the results indicated that the impact of almost all tested factors were as I hypothesized, meaning that the hypothesized most protective values significantly decreased the risk and increased willingness to purchase, and least protective values significantly increased risk and decreased desire to purchase. Based on the factor coefficients from the regression models, I then ranked the effectiveness of the attributes from the label in terms of changing participants' risk perception and willingness to purchase. Let's start with risk perception. The top three attributes that significantly increased participants' perceived risk were sharing data with third parties, having no access control, and the most effective one was selling data to third parties. On the other end of the spectrum, the top three factors that significantly decreased the risk perception were having multi-factor authentication, having no data sharing, and the most effective one in reducing the risk was having no cloud retention, basically not retaining data on the cloud. In terms of willingness to purchase, they found very similar trends, which makes sense. So the top three factors that significantly increased participants' desire to purchase smart devices were having no device retention, having no cloud retention, and the most effective one was having no data sharing, so not sharing user data. And the top three in decreasing participants' desire to purchase a smart device were sharing data with third parties, having no access control, and the most effective one was selling data to third parties. We also noticed a few security and privacy misconceptions. For example, some of our participants thought that no security update indicates better security. One of our participants said, if there are no updates, then the system must be providing maximum security already. Another said, on the label, it advertises that patches are even needed. That is why there's a perception of decreased privacy. Based on the input from the security and privacy experts and hundreds of smart device consumers, we applied further changes to the content and design of our labels, and this is the most recent version of our label. And as a final component of basically this project that I want to talk about is another study that I did to basically understand whether consumers realistically value transparency, whether they are willing to pay to have this transparency at the time of purchase. As I mentioned at the beginning, and as we all know, smart device manufacturers are not transparent about their devices' security and privacy practices. Over and over, we see these companies collecting more information than promised and needed, and sharing this information with basic third parties that consumers are not even informed about. This lack of transparency can actually create a vicious cycle where consumers are not able to consider security and privacy in their purchase decision-making. And in return, manufacturers would then think that, okay, they don't their behavior kind of showed that they don't care about security and privacy because they're not considering these factors in their comparison shopping. And that basically means, okay, if they don't care, then I don't need to consider security and privacy in one of the important factors, basically, as I'm designing these technologies. And that is basically what I mean by the vicious cycle. Consumers cannot basically consider this information, but manufacturers think that they don't consider because they don't care. And one way to potentially break this cycle is by showing these manufacturers that consumers actually care about having these factors, having this transparency at the time of purchase. And if you show this information, they will consider this in their purchase decision making. And one way to show that someone cares is to basically show that they are actually willing to pay for that thing. And this is basically what we did here. We wanted to understand how much they are realistically willing to pay to have this transparency at the time of purchase. And this study was a very complicated study. And all of these projects, basically, I forgot to mention, but all of these projects are published. So if you're interested in any of these projects, the paper is out there. But the setting of this project specifically was very complicated because we didn't want to just ask someone, okay, how much are you willing to pay? That is not realistic. We wanted to specify the dollar amount that they are realistically willing to pay. So we had to design a study that would basically elicit participants or consumers' true willingness to pay, which basically made it very complicated. So I simulated a comparison shopping study and designed a large-scale incentive-compatible study to measure consumers' willingness to pay for various security and privacy improvements when that improvement is being presented on the label, when consumers know that, for example, that improvement is happening, and when that's transparent to them. For each label factor, I selected 3 levels: low, least protective, medium protective, and high protective. So for example, for the security update, I selected no update as the least protective value, manual update as the medium protection, and automatic security update as the high protection value. I then did the same thing for all the attributes on the label. And what I kind of wanted to understand is if I, for example, tell the consumer that, for example, compared to, let's say, your data not being shared with anyone, now your data is being shared with third parties, or compared to not having security updates, now you're receiving automatic security update, similar to how they would kind of compare to smart devices at the time of purchase. How much are they willing to pay for this enhancement when that information is being presented to them on a label format at the time of purchase? And basically, that's how we kind of set up this study. So I tested 15 security and privacy improvements. And for the sake of time, I'm just going to talk about the most valuable comparison pairs. So for a $60 smart speaker, so that was kind of what we tested, a $60 smart speaker, we created a specification for this device. The most valuable improvement for consumers was having de-identified cloud storage compared to identifiable cloud storage. And they are willing to pay around $13.31 to have this improvement. The second most valuable improvement or valuable information is having password access control, which is $12.74, again, on a $60 smart speaker. And the third most valuable one is having multi-factor authentication versus having no access control. So throughout the study, the majority of the factors or the improvements that we tested made sense. Basically meaning that if something is decreasing the risk, you should be willing to pay more for that. But that was not the case for all the factors. There were a few exceptions. For example, we hypothesized that multi-factor authentication, because it provides more protection compared to, let's say, password access control, participants should be willing to pay more for having two-factor authentication or multi-factor authentication compared to password. But that was really not the case. Although participants said that, I understand that it's basically going to reduce the risk, but again, I'm not willing to pay for having two-factor authentication or multi-factor authentication because it's not usable. One of our participants said, I know that multi-factor is probably more secure, but being able to change the default password is easier. So convenience is basically one of the factors that is kind of competing against security. And people are basically willing to pay more for less secure option if it's more convenient. Another exception was personalization, telling participants that your data is being collected for personalized offers compared to not being used for personalization. Participants were actually willing to pay significantly more to have their information being used for personalization because they found it to be more useful. A participant said, I like the devices with personalizations and they are more useful, but I know that there is an increased risk associated with the personalization as the device needs to obtain more information about the user specifically. In addition to looking into one factor at a time or one information at a time, we also tested how much consumers are willing to pay when kind of comparing three types of, I would say, transparency levels. One would be a label that would basically convey that everything is looking great, everything is protective. The device basically is great from all aspects. A label that shows that all the factors are risky and having no transparency, not knowing anything about the privacy and security of the device. So we also designed an incentive compatible experiment to basically compare these three levels of transparency: most protective, least protective, and not having transparency. So basically what we found is that, one of the findings was basically not surprising, which is that if you tell consumers that everything is looking great compared to telling them that everything is risky, they are willing to pay significantly more for the device that has more protective basically practices compared to less protective practices. So that's clear. But what was surprising was that participants were willing to pay significantly more to purchase a device that has no transparency, so they don't know anything about security and privacy, compared to purchasing a device that they know that it's going to be risky. So basically what this means is that if transparency, if labeling is not mandated, device manufacturers that don't care about security and privacy, they may actually decide not to disclose their device's practices, because as we've shown in this project, participants are willing to pay even more for no transparency compared to something that shows that it's risky. So that basically is a call for mandatory labeling of these devices. Okay, and in addition to the label that we've designed, we also prepared a specification, a very detailed specification document for consumers and device manufacturers. In this specification, I provided the full taxonomy of the label, a consumer explanation for each of the attributes of the label, as well as the additional information that device manufacturers should provide on this label, and the device's best practices, security and privacy best practices. And for real-world impact, I would love to see our labels adopted. And to ease the process of generating the label, I developed an interactive tool that allows developers to complete a form for different sections of the label and then see the label being generated in real time. In the most current version of the tool, users can download the label in the formats of JSON, XML, and HTML. Users can also work on the label offline and then upload the saved JSON file to resume working on it. And the URL here, you can basically take a look at the tool, as well as on the previous slide, the specification. Okay, to conclude, in a multi-step research extensive process, I designed a usable and informative security and privacy label for smart home devices. I provided empirical evidence that if this information is readily available to consumers, they would significantly value improved security and privacy practices of these technologies, provided that these practices are still usable and convenient. Our results indicated that to be effective, this transparency should eventually be mandated so that device manufacturers get penalized if they have risky practices. Throughout this work, I've been working with the White House, with FCC, with NIST, with Consumer Technology Association or CTA, Consumer Reports, and other organizations to inform the current Cyber Trust Mark program in the US to basically have these labels being developed for smart home devices in the US. And with that, I would like to conclude my talk, and I would be happy to answer your questions.
Fantastic. Thank you so very much. And congratulations again. It's been really fun to hear a little bit more about your work, because at Vision Weekend, we had a very brief talk, but it's really cool to see so much detail. Thank you so, so much. We already have a few questions here in the chat, so we might start with those. And for anyone who hasn't asked anything yet in the chat, it's a reminder that you can ask anything by just raising your hand, or if you can't unmute yourself, you can post your question in the chat and I will ask it. So maybe we start with Alan and then we go to Micah. Alan, please kick off with your question.
She answered my question, which was that she tests the analog of an underwriter's laboratory label, and she answered my question. So,
all right, good. So you're in the clear. Great, thank you. Next one, Micah.
I worry that companies will manufacture devices that score great on the label and then immediately require an update during setup that undermines everything the label said. With a food label, the seller can't change the ingredients of the food after you buy it. This is not true with software and hardware with software on it. Do you have thoughts on how to protect consumers against that? Like, I feel like that's kind of the inevitable end game here if you don't.
Yeah, that's just a really good question. I would say that the current program that you're going to have in the US with the Cyber Trust Mark, so they're going to basically have a minimum requirement, they're going to mandate a minimum requirement for manufacturers to get this, to get certified and to have these basic labels. That minimum requirement, still, we don't really know what that's going to be. So NIST is working on that minimum requirement document. But the idea here is that if it passes that minimum requirement, the device is secure to basically to some degree. So that the requirement, for example, might be the device receives security updates, or the lifetime is to a specific, for example, date. But I think the question on, for example, if they say something on the label and they change this, because of that kind of concern, the current label that we are going to see in the US, it's not going to include much information on the packaging itself. So the label is going to be only a QR code and a URL on the package. Everything is going to be online. And the idea is that if the manufacturer is changing anything, they have to update the consumer, basically. But nothing is printed on the package, so that if they change it, for example, consumers would kind of not know about it. So the whole thing is basically online. But again, everything is still ongoing, basically. All this conversation is ongoing. FCC is overseeing the whole program. UL is working with different organizations to be able to test the accuracy of the information that manufacturers provide. So a whole thing is still basically, people are kind of thinking about how to design the program. But it's basically ongoing, and it's going to be an alternative to privacy policies.
You get a thumbs up there. All right, wonderful. Next one, we have David.
So this was really interesting and great work. I'm wondering a little bit about the incentives of companies and how much of their revenue is actually coming from products versus the data that they're gathering and the other things that, like, if the commercial incentive is to make sure that they have the data, I worry that, whatever labeling efforts there are doesn't do the right thing. So I was just wondering if you had looked at or thought about how much of the revenue does come from the product versus the service versus the ads.
So thank you so much for the question. This is, I think, one of the topics that I'm personally very interested to study in our lab, to really kind of understand this monetary value of basically this information versus the product itself. So I would love to do something like this. But I would say that when we had these conversations with companies, and even at the White House, the security summit that I mentioned, so Google was at the table, Bosch was at the table, Samsung was at the table. So there are a few big players that are going to be early adopters of the Cyber Trust Mark, basically, program. And the idea here is that people, well, if the company don't care about privacy and security, and then if, for example, the user, let's say, is kind of comparing between products, and if the manufacturer kind of knows that, okay, if I don't make this information transparent, maybe they're not going to purchase my product, or maybe they don't trust me, especially for startup companies, like smaller companies. if they don't have a kind of a reputation in this whole thing, it's going to be a competitive factor for them to basically improve these practices and make that transparent. And right now, for example, if you look into the software privacy label or app nutrition labels, for example, Apple and Google, both of them do have privacy nutrition label on the App Store and Google Play. And the idea here is that, well, people care and we want to kind of make sure that we are transparent and on all of those things. So I would probably say that the same, I think, incentive or similar incentive models gonna be for smart devices, because we've seen something like this for software. Though I would also say that when we conducted this project, the majority of these devices did not have these kind of AI component as we've seen right now. So maybe this idea of collecting as much information as possible was not really such a concern at the point. Right now, if we redo the studies, things might change. And another kind of project that we are doing in the lab is to kind of understand for these AI integrated products, even chatbot or smart devices with AI or robots, if transparency is going to be a factor that anyone cares about, if we can make this information transparent, and if companies are going to be on board in providing this information to users. So we're going to test all of this, but I would say that I think it can probably push the needle for some companies if they are more transparent, because users don't know about them, especially in the smart device realm, that there are a ton of companies. So I think transparency could be a nice factor for users to maybe prioritize. But again, not sure exactly how much revenue would come from data versus kind of device itself.
If that answers the question, Pardis. Yeah. Okay, cool. Then we have Micah again.
So I think the user intuition is actually right on the automatic updates, even if their reasoning is wrong. I worry about grading automatic updates strictly better than no updates, because like in a perfect world, automatic security updates are great. Everybody protects them properly and companies never exploit them, etc. In the real world, companies frequently update software and either make it worse or change their privacy policy in the process, start gathering more data, do bad things. Hackers get access to the keys to deliver automatic updates. They can hack into it. And so I kind of worry about, on a label, this kind of sort of grading system saying automatic updates are better than no updates. Like manual updates maybe is the best. It's unclear. I don't know how to express this in a way that is easy to understand to users, but at the same time doesn't just give them a false sense of security and encourage companies to add automatic updates when they don't think they need them. Because now you're adding a backdoor that you could have otherwise avoided, but I need to do it to get the label, the gold star or whatever. You have any thoughts on this general?
Yeah, that's a great question. Again, I'm not 100% sure what's NIST's status on this right now. But based on my last read of the document that they've published, it's not about whether automatic update basically is going to be ranked higher compared to no update. But the idea is that whether the device can receive updates, whether the device is not going to get updated, basically, or the lifetime is going to be super short. So I think the idea is between no update versus some updates. It can be manual update, it can be automatic update. So that's, I think, what NIST is kind of saying, that device should be able to receive updates if updates are needed. But there are devices that cannot receive updates, or that the lifetime is basically pretty short. And if it expires, they're not going to tell the consumers that from now on, your device is not going to get updated. But I do agree that in our studies, we actually kind of hypothesized that automatic updates should be better or more secure than manual, and manual basically more secure than no update. But again, in kind of real world, it's going to be whether the device can get updated or not. And I would probably say that the ability for the device to get updated, if that's needed, I think it's more secure than just device not being able to get updated at all.
We have another thumbs up here. And we have a comment from Dean in the chat. Dean, feel free to raise your hand and mute yourself anytime as one of the sponsors of the prize together with Protocol Labs. We would love to hear from you and Agaric.
Well, my comment in
Dean,
the chat was merely
go for
about the auto updates, but so it's very minor. But at a high level, congratulations. I like I think in some sense, the most important thing out of what you did was you had solutions and you tried them on actual users and got real data, right? That are all about and relevant to usable security. And so the details we're talking about now is of the particular thing, which is really important. But that meta lesson of, it's worth actually going and trying stuff with people and measuring it and all that, just amazing. So thank you.
Thank you so
Awesome.
much.
Thank you, Dean. Okay, I'll have a few more general questions, and anyone here in the chat can interrupt me anytime by raising their hand, which Alan just did. So Alan, go for it.
So often say that they'll pay more for something, but when it comes to actually spending dollars, they won't. Was there some way that you tested them to see if what they said, the extra $12 they pay for the smart speaker was real? Or was it just, yeah, I'd pay that much?
Yes, so that's actually, yes. And I would be happy to actually send you the paper basically that we wrote. It has all the details, but the way that we did this in the experiment was that we basically told participants that they will get no compensation by participating in the study except for a discount coupon. And the amount of discount that they will receive is basically based on their responses to how much they are basically willing to pay. So for example, let's say that there's a $12 premium. So the maximum discount that they can get, let's say, was $25. If they are willing to pay $12, that basically means we will only give them $13. So whatever is left basically from the maximum is what they were promised to receive as a compensation. This study was, let's say, a half an hour study, and we told them there's no other compensation, and that's the only thing that you get. It was a deception study. So at the end of this whole study, we basically debriefed all participants that there's no discount coupon, and we paid them all the same money. But that's kind of how we simulated the risk in the study, that they will lose money. If they are basically willing to pay more, they're going to lose money. So they really need to care to basically say that I'm going to pay basically this much money, because if they say zero money, they can get the $25 basically in theory as their compensation. So that's kind of how we simulated this. But then we use a economic method called multiple price list, MPL, which basically is a way to elicit true willingness to pay. So you would kind of show people different tables, and they have to kind of compare two types of product each time. Then you will randomly select a row in the table, and that's how you would measure the compensation. So it has a kind of a whole mechanism behind it. But we try to simulate the risk by just telling them that there's no other compensation, basically. And that's not usual with user studies. You have to pay participants in user studies. But basically, we told them that the coupon is the only thing that they would get.
Cool. Okay, wonderful. Again, I'll just ask a few more general questions that are mostly interesting from a general Foresight perspective. So, yeah, as Dean said, I think the work's fantastic. It's really just like, in the field, you're going out there, you're seeing what actually works and what sticks. If you would not just necessarily like generalize it or see how this could be scaled, but like if you were thinking about like how can this actually have impact in the real world, I think you're already speaking a little bit about like, maybe potentially making something like that mandatory, but like if we think broader, in the theme of the Norm Hardy Prize of actually like making security usable, like actually allowing people to use secure systems securely. What implications does that work have? How could you scale it? How could you really like roll it out to ensure that the systems that we have right now can actually be used in a secure way?
Yeah, that's a great question. I think what we tried to do in the study, of course, that was not the intention from the beginning, but basically, I think kind of the implication of this whole journey was that if you make things usable so that people kind of understand what's going on, if there is a way for them to kind of be able to make decisions based on, let's say, the information that you're providing to them, if something is actionable, that would make real world impact. That they can basically make better decisions. They can make more secure decisions, a more privacy protective decisions, basically. In order to be able to scale a study like this, or kind of, it's hard to measure how effective I think these things are. If you make things usable, doing the user studies, there is usually this risk that whatever you're getting from the user studies are hypothetical, because you're just asking people, do you care, do you not care? But when you want to make this more realistic, which is what we tried to do at kind of the last project, last component, things are getting very complicated. It's hard to recruit people. It's hard to, this study is super expensive. So there are so many challenges with that. So I would say probably I cannot give a recipe of how we can kind of scale this type of research, because each research I think involves its own challenges. But I think it's worth doing that, because if not, no one really listens to these results. When we were talking to regulators, they really wanted to know, did people just say that they would pay, or did you actually really measure it? Like, how did you measure it? So these are, I think, things that people usually care about. So if we don't do this, everything is going to be hypothetical and only in kind of the papers that they publish. But I think this whole journey is worth taking, but you just kind of need to stay on track and make sure that you're not just proposing things that you haven't measured in the wild. And I think that's unfortunately the majority of the research in usable security, that we are not sure whether these are useful. But again, I think having this information by itself it can be useful. But if researchers can basically actually take this journey to the end, it's probably even more effective.
Cool, wonderful. And one question that's more specific to you, if people here on the call and like afterwards, those of them that are hearing it on YouTube are interested in supporting your work, could you just give a brief outline of what's next for you? What are you going to focus on in 2026? We're at the beginning now in January. So what does this year look like for you? And are there any roadblocks or otherwise collaboration requests that you have for people watching this video?
Of course, thank you for asking. So as I said, we did this research when we had these traditional smart devices. We had smart speaker, thermostat, all those things that were kind of traditional. But right now, we are going to have robots. We are going to have humanoids. We are going to have much more complicated technologies that people may welcome to their most intimate, basically, environments, to their house, to interact basically with everyone, their household members, kids, all of that. So I think now in the lab, what we are doing is that we're trying to kind of understand how users' relationship is going to look like with these AI-powered technologies, and what does it mean for privacy? So what are some privacy boundaries that users expect to have for their humanoid technology? How they want these technologies to protect their data? How can we make sure that this is happening? How can the device communicate to the user that they are protecting their information without deceiving them? So there are so many interesting questions that we were not even able to ask when we had smart thermostat. And we are basically going to look into this new direction of AI-powered technologies over the next few years. We started with chatbots. So one of my PhD students, he is looking into people who are using AI chatbots for mental health, and the fact that the majority believe that the information is protected by HIPAA in the US right now. So we are basically looking into designing better privacy protection controls when they are using, let's say, ChatGPT, for example, to share about their mental health. But we're going to expand this direction to sensor-rich devices, to, for example, humanoids, to social robots that people are going to have. So that's basically kind of the direction that we are taking in the lab for the next few years. And I would love to be able to, definitely just brainstorming with everyone here about these directions, that's very useful, but also kind of working more closely with developers, people who are thinking about these designing these technologies, and kind of understanding their perspective, understanding if, for example, we propose that, okay, we need to have these features because consumers are asking for that. Are they even going to be feasible? So what is feasible? What is something that could basically make an impact? And I think having a closer collaboration with manufacturers, with developers, could actually help with this.
Fantastic. Thank you so very much. Congratulations again from everyone here in this call. Thanks a lot for presenting here. I just shared a bit more about you, including a link that contains your email address, CV, etc. So if people have collaboration requests for future, I would say contact you directly. And if you can't find Pardis, you can always go through me. Thanks, everyone. That was a really wonderful first seminar to kick off this year. I appreciate it, and I hope you all have a wonderful day.